In section 70, we look at the properties of logarithms. The use of the calculator is not allowed on this section. So looking at these properties, we just want to review the properties of exponents. So here, what we want to remember is that if they have the same base, we're going to add their exponents together. So I would do, in this example, 2 plus 3, I get x to the 5th. Over here, I would do 7 plus 8, I'd get x to the 15th. Down here, 4 plus 5, I get x to the 9th. And over here, 0 plus 4, and I get x to the 4th. So with that in mind, when we're looking at our properties of logs, if you have the log of a times b, so we're kind of working backwards here. So we're talking about this part on this side. If we're trying to separate these out into two different things, they separate out by addition. So with these, if I have the log of, say, xy, it becomes the log of x plus the log of y. Okay, so when we're dividing, we end up subtracting our exponents. So here are some examples. 7 minus 2, I get x to the 5th. My next one, 9 minus 4, I get x to the 5th. 11 minus 3, I get x to the 8th. 6 minus 5, I get x to the 1st. So thinking along the same lines as what we did a minute ago, if I have the log of a over b, working backwards here, we know that when we're dividing, we end up subtracting. So we've got the log of a over b is equal to the log of a minus the log of b. And then the last thing we're going to talk about is when it's power to a power. And when it's power to a power, we multiply. So again, x squared to the 3rd, we do 2 times 3, we get x to the 6th. For my next one, 1 times 5, it's x to the 5th. The next one, 5 times 4, we get x to the 20th. 6 times 3, we get x to the 18th for that last one. So again, if we're looking at this type of example, if I have the log of something raised to a power, I end up multiplying that power by that log. So one way to think about it is that we're going to move that n out into the front, and it becomes n times the log of a. Because again, power to a power, we multiply. So right now we're going to practice. We have some different expressions, and we're going to want to write them as a single log. So again, you want to remember that if we're adding logs together, we actually multiply their numbers. So this becomes the log of 6 times 5, so the log of 30. In my next one, you want to think about order of operations. So here, I'm going to start with the subtraction here. I've got 12 and 2, and because I have subtraction, I have to divide. So that becomes the log of base 2 of 6 plus the log base 2 of 7. Well, now if I have addition, I'm going to multiply these numbers, and that gives me the log base 2 of 42. Go ahead and try these last two examples. I would pause the video right now and then play it for the answers. Now, in this example here, again, I've got addition. So I'm going to start with 5 times 2, and that's going to give me the log base 3 of 10. And I still have plus the log base 3 of 4. Now again, if these are being added together, I don't actually do 10 plus 4 and get 14. I do 10 times 4 to get 40. And that becomes the log base 3 of 40. And for my last one, I start with 8 times 6, so I get the log base a of 48 minus the log base a of 1. And then subtraction means we're going to divide, so I'll do 48 divided by 1, giving me the log base a of 48. So here's some other examples that we'll look at. In this first expression, I've got the log of y plus the log of x. Again, if we're adding, we multiply, so that becomes the log of xy. For my next one, I'm subtracting, and one thing we need to realize here is that they have to have the same base. And when I'm subtracting, I divide. And then this is the first time we've seen an example with this one. Here, if you've got this number out in front, we want to remember that multiplication is going to come from power to a power. Power to a power with exponential form is when we would multiply. So here, this becomes the log base 6 of 2x to the negative 4th. From there, you could rewrite that because we're not supposed to have negative exponents. 2 to the negative 4th would make that 2 to the 4th in the denominator, which becomes 16. And then we also would have x to the negative 4th, which changes to x to the positive 4th when we move it. So for this next example, this involves a couple of properties. The first thing that we're going to deal with is the multiplication here. I'm going to make this 2 go as the power on 8 and the 5 go as the power on z. So we write it as the log of 8 squared plus the log of z to the 5th. Then, because we're adding, we're going to multiply those parts together. So it's 8 squared z to the 5th, or we could write that as 64z to the 5th. So we've got the log of 64z to the 5th there. On my next one, again, I want to deal with all of those exponents. So anything listed in front of each log becomes the exponent on the number that's right here, or the variable that's right here. So that's where we're getting the log of x to the 3rd, the log of y to the 4th, and the log of z to the 4th. Then I've got addition right here, which means I'm multiplying. So I get the log of x to the 3rd, y to the 4th, minus the log of z to the 4th, so subtraction means to divide. So I keep x to the 3rd, y to the 4th in the top, z to the 4th goes to the bottom. And then for my last one there, again, they have the same base on each of those, so I can go ahead and apply my properties. There's nothing out in front that needs to move, but at this point, since it's subtraction, I divide. So it's the log base 1/2 of the square root of x over x to the 3rd. I could also rewrite that. That numerator, x, the square root of x, is the same thing as x to the 1/2. So then if I did 1/2 minus 3, that would end up giving me negative 5/2, and that's just another way to express that. And for this part of the lesson, we're going to stop here. So this gives you an idea of how we're simplifying any of these expressions. Please complete the associated problems now with that lesson.